Hi, in this video I'm going to show you how you can interface C++ code to Matlab. This is convenient because you can use C to send data directly to Matlab and then use Matlab to visualize your code. This is an excellent tool for doing rapid debugging or code visualization, which is typically pretty hard to do directly from C. So in order to demonstrate how this works, I've created a pretty simple routine. There's a lot of code here, but I'm just going to start by cutting to the basics. So what I'm going to do is I'm going to start by initializing an array of x and y. X is going to contain cosine t, and y is going to contain sine t. And then what I'm going to do is I want to create a linear sum of x and y. So some constant a times x plus some constant b times y. And then I want to plot that. And I want to plot that for different values of a and b. So this is a pretty contrived example just for the purposes of the demonstration that I'm trying to do. But I think what you'll see is that it demonstrates quite nicely how you can use Matlab to visualize your code. So again, all we're trying to do is a cos t plus b sine t for different values of a and b. So I'm going to, first thing I need to do is I need to make sure I include a header file called engine.h. And that, if you have Matlab, you have engine.h. The next thing I need to do is to declare a variable, which I'm going to call ep, and ep will be a pointer to a type called engine. And I'm going to initialize that with the engopen function, and essentially what this command does is it's going to create a link to Matlab. And every time I want to talk to Matlab, I'm going to make sure that I use the ep variable as my link between C and Matlab. So here I'm just declaring my local variables, nothing fancy here. Alright, so this is where it gets a little bit tricky. So Matlab has this data type called mxArray. So the mxArray is a mex type array, and it's a fairly complicated data structure with all sorts of odds and ends in there that's necessary for C to capture everything that's in a Matlab array. If you think about the sophistication of what Matlab allows to go in a data type, there's a lot going on there. There could be multidimensional structures, there could be cells, there could be all sorts of things. And all of that is captured within the mxArray data type. So there's a lot going on there, but then Matlab has given you some pretty simple functions for accessing the parts that are important. So what I'm going to do here, I'm going to create a data point called zArray. So that'll be a variable, and it will be a pointer to mxArray. And I'm going to initialize it using this command. So mx create double matrix is essentially saying create a double matrix, double precision matrix with 1,000 rows and 1 column, and I want it to contain real data types, mx real. I'm also going to create two other points, variables. One is called a array and one is called b array. And those are going to be just 1 row and 1 column each, because in those cases I'll only want to pass back a singleton data value. So the next thing I need to do, again, remember I said each of those mxArray data points contains all sorts of pointers and data, and it's a pretty sophisticated structure. It turns out that all I'm really interested in is accessing that position in the array where the real data is stored. So if I run the mxget pointer real function, mxgetPR, it's going to return a pointer to double. And from then on, if I access PZ, that's essentially just going to point to wherever the real data is within the mxArray data structure. So now I have a handle to get directly into where the data is within the function, within the structure. Great. So now I can come and run my code. I'm going to do my one-time initialization of x and y. I'm going to define some value of a and b. And then what I'm going to do is for each of my 1,000 values of x and y, I'm going to take my current value of a and my current value of b, and I'm going to create the linear sum, and I'm going to store that in z. So again, z is a local variable. But then, instead of just stopping there, I'm going to take my newly created value of z, and I'm going to save it in pz of I. So you'll remember that pz is a pointer to the real data within my zArray matrix. So essentially what I'm doing is I'm taking my newly created values and I'm stuffing them into the mxArray. And that's important because mxArray is the common language that's spoken between Matlab and C. Great. So once I've stuffed my 1,000 values of z into pz, I'm also going to bundle up my current values of a and b, into their respective matrices. And then I'm going to run the eng_put_variable function. So what this is going to do is it's going to say use EP, that's my pointer to the MATLAB engine. So I'm going to say use this pointer, and I want you to take the data that I've created, which I called Z-array. So you've got to send it something of type pointer to mex array. So take Z-array, send it to MATLAB, and when it arrives at MATLAB, I want MATLAB to call it Z. So in MATLAB space, it'll be called Z. Then I'm going to do the same thing. I'm going to put the A array and I'm going to put B array. And then I'm going to run eng_eval string. So basically, when you get to this function, you can put, within these quotes, you can put any command that would be a valid command to type in at the MATLAB command prompt. So in our case, testplot is a mfile script that I've created for plotting my data. And over here we can actually see what that mfile is. So first thing it's going to do is plot Z. How does it know what Z is? Well, if you come back over here, you can see that Z is my 1000 by 1 data array, and when I sent it back to MATLAB, I had it called Z. So plot Z, make the axis the way I want, put on a grid, and then create a title. So in this case, I've used a little MATLAB trick for creating a title that contains the current values of A and B. So for each plot it makes, there'll be a different value of A and B, and those values will get pushed into the title. And finally, I'm going to run the pause command. That's just to slow the execution down a little bit so that instead of rapidly shuffling through all these plots before I can even get a chance to look at them, it'll force MATLAB to wait a tenth of a second between plots. So that whole process is going to get repeated 100 times, and for each of those 100 times, I'm going to use a slightly different value of A and B. All right, and then finally, before the C++ program closes out, I'm going to run the engine close command, which will basically just close the portal back to MATLAB. Okay, and that's pretty much it. So again, just keep in mind that once you've got things set up, this is how you take data and put it back in MATLAB, and then this is how you tell MATLAB to run any script that you like. So now I just need to compile this. I compiled my script using GNU plus C++, and the only thing you have to be a little bit careful about is making sure to include the correct directories for the compiler to find the include file and then the library files. So I kind of had to do a little bit of manual poking around. That's where I found them on my computer. You'll have to look for them on your computer. And you also need to make sure that when you compile it, that you link in the engine library and the MX library, as I've done here. Again, depending on your compiler, there may be a different way of doing it, but that's how I'm doing it. So we come over here, make demo. All right, so that worked. And now I'm going to run the demo function. So here's MATLAB. And now here's my plots. So you can see every one of my iterations, I'm getting a new plot on the screen, and it's even including the current value of A and B right there in the title for me. So a really easy way for me to visualize my data as it's running. So I'm going to run it one more time just so you get another look. A couple things to notice. The first thing is that I'm actually not running MATLAB. MATLAB is not running in the background. It was totally closed. So this little trick works regardless of whether or not you're running MATLAB. The other thing that's important to know is there are a few more tricks that you can use. You can get variables back from MATLAB, so you can send data to MATLAB, manipulate them, and then bring them back. You can also, if you're using a debugger, so if you're using, for example, a development environment that has an integrated debugger, you can actually step through your C code in a debugger, and then you send that data to MATLAB on the fly, analyze it in MATLAB to make sure you're doing things the way you think you're doing them. So all in all, a pretty powerful technique. Okay, I hope this has been helpful. If you have any questions, send me an email. Thank you.